This is Cameron Chai from azonano.com, and I'm speaking to Tom Levesque from NanoInc, and he's going to show us through their DPN5000 system.
Thank you, Cameron. Again, this is the second of our two instruments that we've introduced here at Pitcon this year. This instrument, the DPN5000, is the latest in our Inscriptor family of research tools that are used for nanotechnology. And this is a system that uses dip pen nanolithography to create very, very small structures. Essentially, it has an integrated AFM in it. It allows you to use the AFM for positioning a tip and transferring material to a surface, and then that same AFM can be immediately used to image the structures that we've built. It's capable of making features as small as 15 nanometers, and it operates over roughly a 90 micron by 90 micron area. Remembering that we very often are doing our work with more than one tip, this system allows you to use as many as 55,000 tips to write over a 1 centimeter squared area. Sample size is still 2 inches or so in diameter, and there is a 1 inch by 1 inch rough positioning stage for coarse positioning your samples before the AFM is used to do the nano positioning. The system has a completely new scanner design for it. This was a design that NanoInc made specifically for doing nanolithography, and in particular dip pen nanolithography. It is a system that allows very precise motions. It's a very linear scanner. It's a flexured design scanner. It has a very low noise laser system in it so that we can image the devices in lateral force mode, which is a method that we use for measuring devices that or structures that have been built that have very, very little topography. These are often done with alkane thiol molecules that form self-assembled molecular layers on surfaces, and these may only be a couple of nanometers in height. So we use a friction mode to image these. It also has a brand new Linux controller. It's a very, very reliable and stable system. There's a great deal of information that moves back and forth between the imaging and the lithography patterns. So it needs this capability to move large amounts of data quickly between the system and the controller. If we look over on the monitors, we can see where the user interface is, and you can see a couple of things there. In particular, on the left-hand monitor, you see a series of letters that spell out Pitcon. Those letters are actually composed of dots. The dots will in fact be what we use to create the structures. You can see when we blow this up that the dots are actually, how big are the dots, J1? 100. Okay, 100 nanometer size dots that are actually used to create this word Pitcon. Two things you'll see on the right-hand monitor are some of the software we use for determining the dwell times, remembering that the length of time that a tip stays in contact with the surface will affect the size of the feature that we create. It's possible with the system to run a series of different times and then calculate the appropriate dwell times to create the feature sizes that you want. Now, if you minimize that screen, you can go back and see the end result here that was created. The Pitcon logo was created in a matter of probably around 30 minutes to do a lithography to create that, made up of thousands and thousands of those 100 nanometer size dots to create that feature. Again, it's made up of mercapto hexadecanoic acid on a gold substrate, and the darker areas are created because of the difference in the friction when the tip scans over it. So that's the DPN5000 doing dip pen nanolithography, actually doing this here at the show.
Right, Tom, and the DPN5000, that's aimed primarily at the research market, you were saying?
This is a high-end tool, again, aimed primarily for people that want the versatility to do the development of inks in the nanotechnology world. It does give you all the features of a high-quality atomic force microscope as part of the system, and we think that people will start off with our DPN5000s to do basic research, and we hope that in the future, when they want to begin to build and produce things, they'll move to the more production-worthy the NLP2000 platform to get the ability to make things in higher volume.
And for this particular system, it comes with an environmental chamber, you were saying there?
Oh, right. You might have missed the fact that it's in a big box here. This box allows you to control the temperature and humidity to get reliable and repeatable depositions. This is a system that gives you about -2 degrees below ambient to +10 degrees above ambient, and a humidity from 5% to about 95% humidity.
All right, sounds like a very versatile system and a good place for people to get started if they're looking to do nanolithography then.
It's desktop nanofabrication, Cameron. It really allows somebody to build things without a whole clean room.
All right, Tom, thanks very much for that. And we hope the DPN5000 and the NLP system are a big success for you.
We hope so too. Thank you very much, Cameron.